Hello, my name is Eric, and welcome back to the Game Devlog series. In episode 0, I covered what my plans were for the game and for the series. I was originally going to make an episode 0.5 or something to that effect to showcase what had already been done as a point of reference, but I've decided to mix it into this episode because there's actually some development to see already. For some background, this game is being programmed in Love 2D, a free toolset for games and software. It uses the Lua language, which you might recognize from other applications, such as the scripting language for Roblox and World of Warcraft, as well as being the language that the Computercraft Minecraft mod uses. I recommend Love for those who are looking to get into game development. It's not like Unity or Unreal, where you have an entire tool suite with an existing engine. Rather, Love offers you the ability to program in such things. This is great for customizability, but the fact that I'm attempting to make my own game engine on top of it may suggest to you that the base abilities of the framework can only be stretched so far without the help of some custom tools. I mentioned my level editing tool / game engine thing called Amethyst. It's in a very bare bones state, with a few objects patched in for testing purposes. The engine is not my main focus for development today. I've been wanting to program a terrain brush, basically like painting the ground layer of a game, and having the tiles auto-join together. In a project separate to the Amethyst workspace, I developed a very basic version of what I'm looking for. This engine works by taking a user-defined set of coordinates from a tile atlas and storing those in an instance of my tile brush class. This class can then return the tiles needed to the renderer built into my tile map class to be drawn on screen. You can put these tile maps on different layers to avoid connections between unlike materials, as well as to get that layered look. The problem with this setup is that it's kind of a mess. I threw it together in an hour, which meant that the code was messy, and all the features weren't implemented immediately, making it hard to work on after the fact. I first tried to add in the features that I wanted to the existing engine, but I quickly found out that it wasn't going to work. The code was just too unmanageable. So I started from scratch, using the old code as a base to remedy my mistakes. This time, I implemented a tile class, where each tile could decide, for lack of a better term, what visual style it should adopt on its own. This removed the need for a lot of spaghetti code that was present in the previous incarnation of the tool. It took me a long time to figure out the best way to decide how that determining process would work. Most of the time-lapse you're seeing is me just tweaking the conditionals to get the correct result, which overall took me about an hour. The biggest issue I had was with what I called joints, sections where the two rounded pieces would have to come together. In my previous version, joints were straight up not implemented, at first because I forgot about them, and then because I found out that it would have been too hard to add using that old code. Here are some very basic sketches that I used to figure this out. You can see in this second image how I've named each section of the tile atlas. Once I got all of the tiles to select themselves correctly, I went ahead and optimized how they are drawn to the screen. Each tile has a draw method, which allows them to draw themselves, rather than having the tile map draw on their behalf. However, having thousands of tiles drawing over and over again 60 plus times a second isn't efficient. To remedy this, I've implemented the usage of the graphics library's canvas feature. A canvas is something you can draw a bunch of things to once and then draw the entire canvas as a whole. Think of it this way: instead of drawing 1,000 tiles 60 plus times a second, you draw those 1,000 tiles once to a canvas and then draw that canvas 60 times a second. This canvas is re-rendered every time a tile is placed or removed, therefore presenting the updated state of the canvas. This could mean that later down the line, when worlds are super duper big, performance could slow down because eventually adding or removing a tile will still require a bunch of things to draw themselves. If this happens, the map designer could use different layers to get around this problem. However, I don't think this problem is likely. The amount of tiles that we would need to see a performance decrease would probably be in the millions. Sorry if the audio quality is pretty bad, it's hot and I have fans on, but I finally, it only took me about an hour and a half, got my tile engine to work. The old one was really kind of wacky. I kind of just slapped it together. And so I decided to sit down and actually write it so that each tile is its own object that can make decisions for itself, I guess. And so as you can see here, it'll make nice little islands, and it will add joints to corners if needed. And the only time it kind of looks weird is when there's no rule. Like here, I don't have a single tile that will wrap this nicely, so it just kind of stays center. But yeah, even if you leave a hole in the middle, it'll kind of make a nice, hole in the middle. I think my next steps are implementing both the tile brush and tile map classes into the existing editor, which I'm sure is going to take a lot of work. I might have to rewrite how the UI interface works, which is kind of a meme because it seems like I'm always writing a UI engine, but this will ensure that everything is cohesive. Overall, I'd consider today a success. I hope you enjoyed watching and maybe you learned something. If you liked the video, consider subscribing. I'll be uploading these update videos somewhat regularly. I'm getting into the habit of recording what I do as part of the development process so that there will always be a video to make at the end of it. Thanks for watching, and I hope you have a great rest of your day.